So please let me know whether the screen is visible. Is the screen
Yes, sir.
visible?
Yes,
Okay,
sir.
thank you. So we have started with the solution of linear differential equation. In the last lecture, we have discussed uh, that the definition of nth order linear differential equation, right? And its solution we have proceeded with. So the definition of LDE is a differential equation which contains the differential coefficient and a dependent variable in the first degree, and which does not involve the product of derivative with another derivative or with the dependent variable, and in which the coefficients are called constants. It's called linear differential equation with constant coefficient. This is the standard form of LD with constant coefficient of nth order, right? So we have seen the question also. Method of solution we have started with. So the first step towards the solution is we have substituted the operator capital D, operator capital D there, which is a derivative with respect to x. And when we substitute into the equation, we will get the capital D form of the equation, that is of the form phi of D into y is equal to f of x, where this phi of D is a polynomial of degree n, right? Polynomial of degree n, and the variable is D there. So the solution of this differential equation, so this is the reduced standard form of linear differential equation of nth order, and its solution is called the general or the complete solution, which is the combination of two sub-solutions, complementary function and particular integral. So we have started with the complementary function, right? We have discussed the formula. Depending upon the nature of roots of its auxiliary equation, we have the formula for the complementary function, that is Cf is equal to C1 e to the power m1x plus C2 e to the power m2x plus and so on Cn e to the power mnx. Right? We have discussed the explanation behind the formula also. Hmm? So let us now proceed with the further discussion. That is, just now we have seen the formula for m1, m2, and so on mn as a root of auxiliary equation. Let me write in short the roots of auxiliary equation. What is the auxiliary equation? Phi of d equal to 0, right? We write the complementary function to be Cf is equal to C1 e to the power m1x plus C2 e to the power m2x plus and so on Cn e to the power mnx. So this is in general formula for the complementary function. But now the question is, if these roots are, we all know that the nature of roots can be of mainly two different types, that is either the roots can be real or the roots can be imaginary, right? The main two types. So in that also, if the roots are real and distinct, then what is the formula for the complementary function? If the roots are real and repeated, then what is the formula? If the roots are complex distinct, then what is the formula? And if the roots are complex repeated, then what is the formula? So based on the nature of roots, we have the four formulas of the complementary functions. I'm writing here based on nature of roots. We have different forms of complementary function. Okay. So the first nature is if roots are real and distinct. Real and distinct means the roots are not repeated and the real. So suppose if we have the roots m1, m2, and so on, mn are real and distinct root, then the formula for the complementary function is then complementary function is the same as we have discussed earlier, that is Cf is equal to C1 e to the power m1x plus C2 e to the power m2x plus and so on Cn e to the power mnx. But now the next nature is if the roots are real and repeated or equal, we can say if the roots are real and equal, right? So in this case, the formula is, suppose if we consider the first two roots to be repeated, that is, suppose m1 equal to m2 and the rest roots are non-repeated, m3, m4 and so on, mn. Okay? So the formula for the complementary function is then cf is equal to, I'm writing the formula and then we will discuss the logic behind the formula. So cf is equal to, am I audible clearly?
Yes, sir.
Hello? Okay,
Yes.
cf
Sir.
is equal to, so please let me know if I'm not audible or if the screen is not visible. Okay. So CF is equal to C1x plus C2 the whole times e to the power m1x plus C3 e to the power m3x plus and so on Cn e to the power mnx. So as we have discussed in the last lecture that the number of roots of auxiliary equation is equal to the number of arbitrary constants involved in its complementary function. So जैसा कि हमें पता है कि इस auxiliary equation को कितने roots है जितनी उसकी degree है. So as we have considered the nth degree auxiliary equation, then it will have n number of roots. So its complementary function involves n arbitrary constants. ठीक है? So these are interrelated things, number of or degree of the auxiliary equation, or the, we can say, order of differential equation is equal to the number of roots of auxiliary equation, and it is equal to the arbitrary constants involved in its complementary function. So here the roots are, number of roots are n, but out of those roots, n first two roots are repeated. So for those two repeated roots, I have considered the form like this. And then for rest non-repeated root, we follow the same formula, the first one. Clear to everyone? Now let us discuss the logic behind this formula, why this is so. So to discuss the logic, let us start with the differential equation LDE of linear differential equation of second order. So if that equation is of this form, phi of d into y is equal to f of x, then tell me uh, how many roots of its auxiliary equation will have. We are considering the homogeneous equation, homogeneous differential equation, that is phi of d into y is equal to 0. We consider the right hand side for getting the complementary function, right hand side to be 0, right? So its auxiliary equation is, what is the auxiliary equation? Phi of d equal to 0. तो इसके auxiliary equation को कितने roots होंगे, कोई बता सकता है? How many roots of its auxiliary equation?
Two.
Exactly, two roots it will have, because we have started with the second order differential equation. So let us suppose those two roots are repeated. That is, if it will have two roots, if both are repeated, if both the roots are repeated, that is, suppose d equal to m1 is the repeated root, d equal to m1 is the repeated root. Okay. Then what is the factored form of this phi of d? What is the factored form of this phi of d in case of these roots? Or we can write this homogeneous differential equation into its factored form. Will it be like this? D minus m1 into d minus m2 m1 into y is equal to 0. Is it correct?
Yes, sir.
This is the factored form of the homogeneous differential equation. Okay. So what we do, we consider this, for our convenience, let us consider the value of this to be z. So let d minus m1 times y is equal to z, suppose. Okay. So what we will get, therefore this operated on z, that is d minus d, d minus m1 operated on z is equal to 0. Clear to everyone? So by substituting d equal to d by dx, what we will get? We will get of the form, uh, by taking z inside, dz by dx minus m1z is equal to 0. Or instead of this, uh, instead of writing like this, as we all know, this is the homogeneous differential equation. तो इसका complementary function क्या होता है? We all know what is the complementary function for this. Hmm? And the solution of homogeneous differential equation is the value of dependent variable. So that is, the complementary function is nothing but the value of z, and that is equal to c1 e to the power m1 z. Yes or no? Is this clear?
Yes, sir.
Because it's auxiliary equation. इसका auxiliary equation कौन होगा? इसका auxiliary equation होगा d minus m1 equal to 0. So its root is d equal to m1. So based on this root, we can have its auxiliary equation, that is c1 e to the power m1 z. Sorry, not z, that is x. c1 e to the power m1 x. Clear to everyone? Where x is independent variable. So this is the value of z, and when we substitute this value into this equation, what we get? We get d minus m1 operated on y is equal to z. So z we have got to be c1 e to the power m1x. So d minus m1 operated on y is equal to this. Okay. So again, if we resubstitute the value of d, and by taking y inside, we will get the equation of this form: dy by dx minus m1y is equal to c1 e to the power m1x. So if we look at this, is it in the standard form of linear differential equation of first order first degree? Hmm?
Yes, sir.
So this is in the standard form of first LDE with first order first degree, where the value of p of x, what is the value of p of x? Value of p of x is minus m. Value of q of x, what is the value of q of x? It is c1 e to the power m1x. Yes or no? So with this, the solution of this linear differential equation of first order first degree is y into integrating factor is equal to integration of q into integrating factor plus constant of integration, that is c2, right? So let us calculate first integrating factor. क्या होगा इसका integrating factor? I is equal to e to the power integration of p dx, that is e to the power integration of minus m1 dx, so that is e to the power minus m1x. So when we substitute value of I into this, what we will get? Therefore, y into integrating factor, that is e to the power minus m1x, is equal to integration of q, but q is this. So that is c1 e to the power m1x into integrating factor e to the power minus m1x dx plus plus c2, right? So that is equal to c1 I'm taking outside because it is constant, and by laws of indices this is getting equal to e raised to 0, that is 1. Yes or no? So that is integration of dx plus c2. तो क्या होगा इसका? That is equal to c1 x plus c2 y into e to the power minus m1x. So when we take this exponential function to the right hand side, what we get? Y is equal to c1 x plus c2 e to the power plus m1x. Yes or no? So this y is the solution of homogeneous differential equation. We call this as a complementary function. Clear to everyone? Hello, everyone, please do reply. Any doubt, any
Yes, sir.
question? So, this is the logic behind the repeated root formula. So, this is for the repeated root, and the rest is for non-repeated root. This is for non-repeated root, which is same as the previous one. Clear? So, this is in case of repeated root repeated choice. अगर root 3 बार repeat होते हैं, so we will do the same thing. So, I'm giving you the formula directly now. If m1 equal to m2 equal to m3 and the rest roots are non-repeated, then what is the formula? Yes, any one of you? कौन बताएगा क्या होगा फॉर्मूला कॉम्प्लीमेंट्री फंक्शन का? सी एफ इज इक्वल टू c1, we will start with x square plus c2x plus c3. जितनी बार रिपीट हो रहा है उतने आर्बिट्ररी कांस्टेंट्स आ रहे हैं ब्रैकेट में. रिमेंबर, c1 x square plus c2 x plus c3 the whole times e to the power m1 x plus next is c4, right? c4 e to the power m4x. We will write the rest for non-repeated root plus c5 e to the power m5x plus and so on cn e to the power mnx. Is this clear? Any doubt? Everyone, please do reply in chat box. Is this clear or not? Hello, hello, everyone. Yeah, very good. So this is about. हाँ, now कौन बताएगा अगर रूट 4 बार रिपीट हो रहे तो? If m1 equal to m2 equal to m3 equal to m4, then what is the complementary function? Yes, cf is equal to
C1x cube.
x
C1x
cube,
cube.
right? X cube plus c2 x
C2x
square
square.
c3 x
X.
plus c4. The four constants will be there in the bracket. E to the power that repeated root times x plus the rest is for non-repeated root. Clear? तो जिसको कंफ्यूजन है कि x के कौन से पावर से स्टार्ट करे, तो उनके लिए मैं और एक ट्रिक बताता हूँ. हाउ डू वी राइट द कॉम्प्लीमेंट्री फंक्शन? दोज हु आर कंफ्यूज्ड विद द पावर्स ऑफ x, दे कैन राइट लाइक दिस. This can be written as c1 plus c2x plus c3x square. ऐसे भी लिख सकते हो. देन आर्बिट्ररी कॉन्स्टेंट्स डजंट मैटर, आप कैसे लिख रहे हो. ठीक है, तो आप ऐसे भी लिख सकते हो. सो इसको तो वी विल स्टार्ट विथ कांस्टेंट, देन वी गो ऑन इंक्रीजिंग द पावर्स ऑफ एक्स टिल एंड अंटिल द नंबर ऑफ आर्बिट्ररी कांस्टेंट्स कवर्ड. मतलब यहाँ 3 रूट है तो 3 आर्बिट्ररी कांस्टेंट आने चाहिए. तो जब तक नहीं आते तब तक हम एक्स की पावर इंक्रीज करते रहेंगे. क्लियर? इसको भी कैसे लिखेंगे फिर? दैट इज c1 plus we go on increasing the powers of x, that is c2x plus c3 x square plus c4 x cube. Clear to everyone? This is also the correct one. Is this point clear? Hello.
Yes, sir.
So जिनको कंफ्यूजन है कि x के कौन से पावर से स्टार्ट करें लिखने के लिए, वो ऐसे भी लिख सकते हैं. But if it is the question for online examination, then the option, if the option is given in terms of this, then you have to select this. But both the option will not be there, remember. So don't need to worry about it. And in theory, you can write any one of the two forms. So this is the second nature. Now the third nature is if the roots are complex or imaginary and distinct. So we all know the complex roots are of the form alpha plus I beta, right? Alpha plus I beta के form में होते हैं, where this alpha is called real part and beta is called imaginary part. Yes or no? अल्फा इज रियल पार्ट एंड बीटा इज इमेजिनरी पार्ट। तो एक बात है कॉम्प्लेक्स में कि if alpha plus I beta is a complex root, then its conjugate is also a root. Alpha minus I beta भी root होता है, remember. ठीक है? तो इसका मतलब क्या है कि कॉम्प्लेक्स नंबर्स, कॉम्प्लेक्स रूट्स आर ऑलवेज कम इन पेयर, पेयर में आते हैं वो, है ना? तो अगर अल्फा प्लस आई बीटा आपका सोल्यूशन रूट मिल जाएगा, तो अल्फा माइनस आई बीटा ऑटोमेटिकली इज अ रूट। क्लियर टू एवरीवन? क्लियर टू एवरीवन?
Yes, sir.
हाँ, so
Yes.
what does it mean? Complex numbers are always, complex roots are always multiples of 2. Number of complex roots are always multiples of 2. So my question is now, if we have a cubic equation, then is it possible to have all its roots to be complex? If we have a cubic equation, is it possible to have all its roots to be complex there?
No.
No? Then what kind of roots would we will have there for the cubic equation?
One real, another complex.
Mhm. Right. That is possibility that out of three roots, the two roots can be complex and one will be real then. It has to be real actually. So the possibilities are either all the roots can be real or one root can be real and the remaining two roots are complex. These are the two possibilities. But there is no possibility that all the roots will be complex. Clear to everyone because it is of odd degree. अगर इवन डिग्री है तो पॉसिबिलिटी है कि सभी रूट्स कॉम्प्लेक्स हो सकते हैं, राइट? बिकॉज इन इवन डिग्री पॉलिनोमियल the roots or the number of roots will be in multiple of 2, right? So let us now discuss the formula. What is the formula? So with these roots, say if alpha plus I beta, let us call it as m1. M1 is alpha plus I beta, and m2 will be alpha minus I beta are complex roots which are distinct also, right? Then what is the formula for the complementary function? Then CF is equal to complementary function. CF is equal to, we all know that C1 e to the power m1x plus C2 e to the power m2x is the formula, right? So if we substitute the value of m1 there, C1 e to the power m1, what is m1? Alpha plus I beta. And C2 e to the power m2, what is m2? E raised to alpha minus I beta x, right? So that can be written as C1 e to the power alpha x into e to the power I beta x plus C2 e to the power alpha x into e to the power minus I beta x. Yes or no? So we can take e to the power alpha x common, and inside it will be C1 e to the power I beta x plus C2 e to the power minus I beta x. And we all know, you must have seen these formulas, that e to the power I theta can be written in terms of cos and sine. That is cos theta plus I sine theta. Do you know this formula? And e to the power minus I theta also can be written as cos theta minus I sine theta. Yes or no? Have you seen these formulas?
Yes, sir.
These are called Euler's formula. Okay. So with this, we use these formulas for this e raised to I theta and e raised to minus I theta. So what it becomes then? It is equal to e raised to I alpha x into C1 cos beta x plus I sin beta x, right? Plus C2 cos beta x minus I sine beta x, isn't it? So that is equal to e raised to alpha x into, I'm writing now, c1 plus c2 times cos beta x plus I c1 I c1 minus I c2 times sine beta x. Yes or no? So this is constant and this is also a constant. So with this, I can write the formula as a e to the power alpha x into uh, a cos beta x plus b sine beta x. So this is the formula for the complementary function in case of complex distinct root, where a and b are the arbitrary constants. Clear to everyone? Hello.
Yes, sir.
So this is the formula in case of roots to be complex distinct. Now the fourth nature is if the roots are complex repeated, complex equal roots are there. Suppose if we have alpha plus I beta repeated twice, then its conjugate will also repeat it twice, right? So how many roots in total we have? Hmm? How many roots we will be having in total? There will be four roots, right? तो फोर रूट्स मतलब कितने आर्बिट्ररी कांस्टेंट्स आएंगे कॉम्प्लीमेंट्री फंक्शन में? Therefore CF is equal to how many arbitrary constants will be there in its complementary function?
4.
Four arbitrary constants. Very good. So how do we write? We write the complementary function to be e to the power alpha x into c1 cos, actually the roots are repeated, right? So we do the same thing as we have discussed in the second case. So I'm writing directly the formula here, c1 x plus c2 times cos beta x plus c3x plus c4 times sine beta x. So you can see the four arbitrary constants are there, right? As the number of roots are 4. Clear to everyone? This is the formula for the roots complex repeated. So in case of root repeated 3 times, how many roots in total we have? अगर 3 बार complex root repeat हो रहे हैं तो उसका मतलब totally we have 6 roots, right? Yes or no? So for the 6 roots, how many arbitrary constants? 6 constants will be there. So how do we write? We can write it as a c1x square plus c2x plus c3 cos beta x plus c4x square plus c5x plus c6 sine beta x. The whole times e raised to alpha x is the complementary function. ठीक है? Hello. Is this point clear? Hello. Everyone, please do reply. Is this point clear?
Yes, sir.
Yes, sir.
These are
Yes,
the four natures of roots and accordingly the four formulas for the complementary function. And this is all about the complementary function. इतना ही है इसमें. अगर आपको clear है कि nature क्या है, according to that formula क्या है, then you'll be getting full marks for this complementary function. Okay. So for example, uh, if we have the question example solve d square plus 2d plus 5 times y is equal to 0, then what are the roots for this? We its auxiliary equation is d square plus 2d plus 5 is equal to 0. तो इसके roots क्या हो गए? We use the quadratic formula, suppose minus b plus minus square root of b square minus 4ac, that is 20 upon 2a. तो क्या हो गए इसके रूट्स? -2 प्लस माइनस स्क्वायर रूट ऑफ -16 अपॉन 2a. तो -2 प्लस माइनस 4i अपॉन So that is minus 1 plus minus 2i, right? So the roots are complex. So how do I write the complementary function therefore? CF क्या होगा? Here alpha is minus 1 and beta is, beta क्या है इसमें? What is beta here? Hello. What is beta?
Plus two ones and minus two.
No, beta is just 2 only. It will not be plus and minus. Because the roots are alpha plus minus I beta. तो उसके लिए मैं beta is 2 only. ठीक है? So with this, we get the complementary function to be e to the power real part, that is minus 1 x. X is independent variable, therefore I'm writing like this. But if the independent variable changes, the complementary function will be in terms of that independent variable. So c1 e to the power minus x, sorry, e raised to minus x into c1 cos beta, that is 2x plus c2 sine beta x. Clear to everyone? Is this clear? How do we write the complementary function with the help of formula?
Yes, sir.
Yes, sir.
So this is all about the complementary function. I'll be uploading few homework question on the complementary function on Google Classroom. You just have to solve each question. There will be 5 to 6 questions. Huh? So you have to write the complementary function with the explanation there. You have to upload today only onto the Google Classroom. Hmm? It's easy. It hardly takes 5 to 10 minutes to solve all those questions. Okay, so let's stop here. Thank you everyone for joining. Let me take attendance for 2 minutes.